Do you know how to find position and velocity by integration? If you don't, this is the video for you. How can we find the velocity if we only know the acceleration? Let's say, for example, we have this acceleration versus time graph with the acceleration at 2 points, t1 and t2, and they want us to find the change in velocity between these 2 points. So from prior experience, we already know that the area under the curve is equal to the change in velocity, but how exactly do we use integrals to compute this value? So if we start with what we already know, which is the acceleration is the change in velocity over change in time. From here, we multiply both sides by dt, and we get this expression, which now we can use the integral to solve. So take the integral on both sides, we can get this expression here. And so now we can ask the question, what are the limits of integration? If we remember that we're actually solving for the area under the curve, the limits of integrations for the change velocity is going to be v2 and v1, which correspond to the limits of integration for time, which is t2 and t1. If we apply these limits, we have this expression here. And from here, we can pull out the ax since it's considered a constant. The dt integral is independent of ax. And so now we can ask the question, how do we do these integrals? Both of these integrals can be written as the form below. The integral of 1 is just going to be our independent variable. In this case, it's just going to be t. And we can just compute this integral. It's going to be equal to t2 minus t1. From here, we can use this concept to apply to our two integrals at the top here, and we get the expression below. Now we can generalize this expression. So if we let v2 just equal vx being any later velocity, and then v1 equal vox, which is the initial velocity, and we let t1 equal 0 and t2 equal t, just any later time, we get this expression here. Distribute ax into the bracket, and we can bring the initial velocity to the other side, getting our final answer here. This is the equation to find the velocity at any later time t using integration. And for position, it's the exact same story. So we can just start with the expression velocity is equal to change in position divided by change in time, and we can follow the same steps here. So we can integrate and get this expression, then we can generalize, getting the final answer here. Both of these are going to be useful when solving word problems involving integration.